Bismillahirrahmanirrahim. Assalamu alaikum. Today we will do a very simple experiment. We will place a ball inside the bucket. We have attached a string to the bucket. If we rotate the bucket, the ball will remain inside the bucket. As you can see, the ball remains inside the bucket. Now let's make the experiment more interesting. We will add water to the bucket. We will rotate the bucket by 360 degrees and the water remains inside the bucket. When you swing the bucket, you can feel a pull on your arm because bucket and water want to continue in a straight line and you want it to move in a circle. Newton's first law of motion tells us that an object will remain at rest or move in a straight line unless acted upon by another force. This property is called inertia. In order to make something move in a circle, you have to use a force, a push or pull. A bucket of water can be whirled in a vertical circle without the water spilling out, even at the top of the circle when the bucket is upside down. The spinning bucket of water demonstrates centripetal force, the inward acting force on a rotating object. The water stays in the bucket because of inertia. The water wants to fly off from the circle, but the bucket gets in the way and keeps it in place. The water tends to move in a straight line, but the bucket pulls it in and around in a circle. For the water to remain in the bucket, there must be centripetal force forcing the water to move in a circle along with the bucket. If we draw the free body diagram of a bucket moving in a circle, then when the bucket is at the top and is upside down, then tension is downward, gravitational force is also downward, and centripetal force is also downward, mv square over r. Since tension, gravity, and centripetal acceleration are all pointing downward in negative y direction, we take minus sign with them. Sum of forces in the y direction is equal to minus t minus mg. Sum of forces in the y direction is equal to minus mac, where ac is the centripetal acceleration. Minus mac is equal to minus t minus mg. The minus signs cancelled out. We are left with mac is equal to t plus mg. We know ac, the centripetal acceleration, is equal to v square over r. Therefore, mv square over r is equal to tension plus mg. If we rearrange the equation, we find tension is equal to mv square over r minus mg. At the top of the circle, gravity is downward and centripetal force points toward the center, hence it is also downward. The tension in the string is centripetal force minus gravitational force. There is war between centripetal force and gravity. If centripetal force is greater than gravitational force, tension in the string is greater than 0. The bucket will move in a circle. The water will stay in the bucket. If centripetal force is less than gravity, then tension in the string is less than 0. Then string will slack and you will get wet. If you don't want to get wet, which I am sure you don't want to in winters, then you need to rotate the bucket above the minimum velocity. Minimum velocity is when tension is 0. As we can see, when tension is equal to 0, mv square over r is equal to mg. M cancels out, we get v square is equal to gr, where g is the gravitational acceleration and r is the radius of the vertical circle. Minimum velocity is equal to under root gr. If we draw the free body diagram of a bucket rotating in a vertical circle, then when the bucket is at the bottom, the gravitational force acts downward, tension acts upward, centripetal force acts upward, mv square over r, it is always directed toward the center. Tension and centripetal force are in positive y direction and the weight is in negative y direction. Sum of forces in the y direction is equal to tension minus mg. Sum of forces in the y direction is equal to centripetal force, which is equal to mv square over r. Mv square over r is equal to tension minus mg. Tension is equal to mv square over r plus mg, where m is the mass of bucket and water, v is the velocity, r is the radius of the vertical circle, and g is the gravitational acceleration. At the bottom of the circle, the force of gravity, mg, where m is the mass of the bucket and water, and g is the gravitational acceleration, opposes the centripetal force. In our case, force is provided by the arm. The total force provided by the arm must be equal to centripetal force and gravity to keep the object moving in a circle. Now let's plug the values that I used in my experiment. Mass of water plus bucket is equal to 1.5 kg. Radius of vertical circle is equal to 0.4 meter. Minimum velocity is equal to under root gr, which is equal to under root 10 multiplied by zero point 0.4, which is equal to 2 meter per second. Tension at the bottom is equal to mv square over r plus mg. M is 1.5 kg, v is 2 meter per second, radius is equal to 0.4 meter. G is equal to 10. If we plug the values, tension at the bottom is equal to 30 newtons. For the minimum speed, tension at the top is equal to 0. We can plug the values and we can see that the tension at top is equal to 0 for the speed of 2 meters per second. Let's suppose initial velocity is 4 meter per second, twice as much as the minimum velocity required to keep the bucket of water in the vertical circle. Tension at the bottom is equal to 75 Newton. Tension at the top is equal to 45 Newton. Tension at the top is greater than 0, which means that the water will stay inside the bucket even when the bucket is upside down. Let's suppose initial velocity is 1 meter per second, half the value of the minimum velocity required to keep the bucket of water in the vertical circle. Tension at bottom is equal to 18.75 Newton. Tension at top is equal to minus 11.25 Newton. Tension at top is less than 0, which means that the string will slack and you will get wet. I hope you try this experiment at your home. May Allah bless us all. Thank you for watching. Allah Hafiz.